begin.
Hi guys, welcome back to Xilir Technologies. Today we are going to demonstrate project named Wireless Advanced Robotic Hand. So I will explain block diagram of the project, circuit diagram, component explanation, output of the project, and then code. And now let's start with block diagram. So block diagram, we have two parts here. One is your hand. So one robotic hand will be there like this. Okay, and here this will be 3D printed. Okay, and one thumb movement motor will be here, servo motor number 1, and these will be connected with wires 1, 2, 3, 4, 5, and servo motor will be here S2, S3, S4, and S5. Okay, and this will be connected with Arduino, these wires. You can use any other microcontroller. An RF module will be used here. Okay, and this side, this is the receiver part. So I'm writing this RF, and this is transmitter part. Okay, and here we will have flex sensor, and also known as bend sensor, and gloves will be there, and on gloves they will be mounted. Flex sensor 1, 2, 3, 4, 5. Okay. And output will be given to Arduino microcontroller. Okay, all these will be connected to Arduino, and again RF module will be there. So before circuit diagram, just get the basic idea. So here we have one hand will be moved like this. Okay, so it will create some logic like band sensor move like this, and to Arduino microcontroller and RF module. Here we will receive the signal on the receiver side, and accordingly motor will be moved. Okay, motor will move, and one more thing, button also we have added here for thumb movement. Okay, like this. One movement is like this, all finger will move, and this is the one of the movement. Okay, like this. Okay, and this is the block diagram of the project. These are the components connected. Servo motors, then we have 3D printer, then we have 3D printed module, then we have band sensor, flex sensors. Okay, so these are the things. Now we will create circuit diagram how things are connected together. So guys, now let's see circuit diagram of the project. I have written here RF based robotic hand circuit diagram. So this is the transmitter part. Receiver side we will make this diagram. Okay, and this is your Arduino microcontroller. So A0 to A5 are the ADC pins. ADC pin means if we give 5 volt, it will convert it into 1023 discrete values. Okay, because it's a 10-bit microcontroller. 10-bit means it will have this register of 10 bit 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so every block will show two values, 0 or 1. So we have 10 blocks, so 2 to power 10, 1, 0, 2, 3 if we are including 0. Okay, so whatever value you give here, it will be converted to this discrete value. So value, what is value? Voltage value. So we have band sensor here. So this is one flex sensor I am drawing. Okay, this flex sensor is changeable resistance, you can say, variable resistance. So we have this flex sensor as one. Then we have to connect one resistance to create voltage between them. Okay, so it is also known as voltage divider circuit. So we have 10 kilo resistance. You have to put one resistance here, 1 kilo, 10 kilo you can use here. So connect that resistance to this, because this is also resistance variable. You just think of this like a variable resistance. Okay, this pin you can give 5 volt, and this pin you can give ground. Now here will be the output, which will be connected to A0. Now what will happen if you bend this finger? Okay, so this resistance will change, and the change in the resistance will create voltage variation here. Okay, and formula for it is like this is, I am marking V0 and this is V in. So this is R2 and this is R1. Okay, so V0 equals R2, R1 plus R2 into Vin. So voltage will be generated here, different voltage. Same way 5 plus sensors are here, F2, F3, F4 and F5. And one button is used here. If you press that button, one more signal will be generated. So assume if this finger, like if you press, you bend one finger, through RF module, some commands will be sent, like A0, or just name it A, B, different versions, different command. These command will be received on the receiver side, A, B, C, D, E, F. Okay, so now on the receiver side, we will have motors. Okay, motors are servo motors. You can use small servo motor also, but I will prefer you use the bigger one. Okay, so that you can get better torque for bending the fingers. Otherwise, they won't be able to do that task, and also gear will slip. Okay, and also you can use metal gear, better one. Don't go with a very costly one. Normal is fine, like 500 rupees, 800 rupees motor is good enough. Okay, so here we have this 3D printed model. Okay, like this. Okay, and slot for servo motors S2, S3, S4, S5. Okay, so each finger have 3 modules for bending. 3 plastic modules are there again here. Okay, well, what we have to do, we have to add one spring here, spring thread I can name it. So it will be stretched, like if you put thread here, it will be stretched. Now you need one more thread, so servo motor can move it, like if you use servo motor, like it will bend like this, and it will bend like this. The spring will maintain the this part. Okay, like it will be like straight, and this servo motor will be like this. This servo motor will be like this, and this servo motor will help like this. Okay, so this way. So I will also show you. Let me show you. It will be like this. Okay, so these motors will help in moving the fingers, and here the threads are the springy threads. Okay, so now let's see further. So here also Arduino is here, and NRF, remember, it will be connected to actuated protocol. Okay, so NRF module has some connections, OZ, MISO, then we have SCSN, CE, SCK. Okay, I will add the picture. Okay, then we have VCC and ground. So it's a complex one. So you have to connect Arduino. Arduino has a specific STI pins here. So you will be directly, you have to connect it. And where you will fail, let me tell you, that is the important part. You have to give proper power supply to the module. You have to use 10 microfarad or 47 microfarad or 1000 microfarad capacitor in between these. Remember this thing, this is very important part. Okay, otherwise it won't be stable and signal won't be received. Okay, and use similar pair. Don't use like 100 meters then 1 kilometer in a different versions you are switching. Use the similar type. Buy from one place and two modules similar one. So that then only they will communicate with each other. Okay. Same copy paste here. Same thing. And then Arduino again. From D2, D3, D4, D5. Okay. And D6, because here we have 6 servo motors. Okay. S1, S2, S3, S4, S5, S6. Okay. So this will control this. This will control this finger. This will control this finger. This will control this finger. This thread I'm marking. Okay. And whenever we receive the signal, things will work. Okay, like this. Okay, and then let's connect like this. NRF on here. NRF, RF module, Bluetooth, LoRaWAN module, Zigbee, any wireless module you can use. Concept now you know how to communicate with each other. Okay, and this is the important part. Flex sensor. You have to create one voltage divider circuit. Okay, so that voltage is divided. If voltage divided, deletion we will receive here, and through that deletion we will know that finger is pressed, and when finger is pressed, we will receive output here. And in the code we have written, if A is received, just rotate the servo motor 90 degrees. It's like this. If we moving like this, so finger will be bent. Okay, finger will bend. Now everything is clear. I think yes, mostly. Connect the servo motor to 5 volt stable power supply, 3 ampere minimum. Otherwise, what will happen? These will not get proper power supply, and they won't work. Okay, remember this important part. If you are using 12 volt battery, 9 volt battery, eco battery, then we need a voltage regulator circuit also. Okay, we can add that circuit also. Otherwise, you can use a direct adapter. If you want to make it portable, just use the battery and 705 power supply. Okay, that's it. So guys, now let's see how components are connected together. So this is 3D printed model. Okay, so we have 3D printed this using our printer, and these are the flexible wires we have connected, and this is your nylon wires here, and then we have servo motor here. This is also known as 9G servo motor. Then we have these strong servo motors, MG995. You can use this one also, but higher chances are that it will break, so use this one. This is better one. Okay, then this is for this left right movement. Okay, and these are finger movement, which will be controlled by this and this pair, then this pair and this pair. Okay, then we have NRF module. This is known as NRF module. Use capacitor, otherwise you will face problem. Okay, this is must. Then we have power module here, so we will give 5 volt here. This 5 volt will be given to this power module. So this is just like a distribution network. Then we have Arduino UNO microcontroller, through which power supply we have given, and these are the connections like this I explained. D2 to D6, then S1 to S6. So these are servo motor connected from these D2 pins to S1, like D2 to S1. Similarly, others. Okay. This is the transmitter side. Transmitter side, again we have this flex sensor with 10 kilo ohm resistance with each flex sensor. You can see here. Okay. Then Arduino UNO microcontroller. Then this glove, and on glove we have one button and flex sensor like this. Okay. So this is our complete project. Now we will see output of this project, how it will work. Okay.
Hello everyone, we are from Xilir Technologies, New Delhi, India. We develop research-based software and hardware projects and products globally. Xilir Technologies has the largest collection of projects. On our website, you can get services like unique engineering projects, science projects, MTech PhD thesis guidance, self-learning kits, ready-made projects, hardware components, drone-related services, softwares and simulations, research paper writing and publications in top journals and conferences. We also provide patent-related services. So to upgrade your knowledge, you can join our channel. For more details, please check description. Thank you guys. Have a nice day.